So welcome everybody. Good to see everybody again. This is still a packed house, which is exciting. This is scaling LMAPs. So what do I mean when we say scaling? Like what exactly are we referring to? Essentially we're talking about going from a small app to a big app. So there's a lot of things that go on in between. You know, you've got features, you've got changes, you've got writing more code. And so the process of getting from the one to the other is what I'm going to refer to as scaling. So yesterday, Evan gave a talk called The Life of a File that sort of focused on the micro level of this. Like what if you got one file, one module, and you want to sort of scale that up. You want to build it out, eventually split it off into 2 files, 2 modules, things like that. So this talk's going to be about sort of the macro level, like the big picture, sort of the general tactics of scaling successfully in Elm. But the basic pattern that we're going to follow is sort of the same thing that Evan talked about. So initially we're going to just build more stuff. Build things, build things, build things. And eventually, after we've built enough things, we're going to sort of look at what we've built, and we're going to discover things. We're going to realize, oh, you know what? Actually, there's some patterns here. There's some things that are grouped together logically that we can split out. And then once we discover these things, we will refactor to sort of make things nicer based on these discoveries that we've had. And then we'll start the cycle all over again. We're going to build more stuff, build more stuff. So sort of build, discover, refactor is just the general pattern of how to build up an LMAP and keep it nice and maintainable. If you want, you can just do the build thing, but you're probably going to discover after a while that you've made a mess. So it's important to think about things, let yourself discover things about your own code base, and then refactor to make things nicer based on those discoveries. Still, as we scale up, things change about our code, right? Code gets harder to find. So you have this question of like, okay, I built this thing, and now I need to modify something. Like, where do I go to actually change the code to make this modification or to add this new feature or to delete something? When you have more code, it's just harder to find things. Also, code can get too big to fit in our heads. We get to this point where, got a little bit of slide lag. Code gets too big to fit in our heads where we sort of like, okay, I just like can't think about this whole system anymore. There's just too much. And then finally, code potentially gets duplicated if we're not careful. We have to reuse things in careful ways to make sure that this doesn't happen. So let's start with looking at hard to find. What do we do when code gets hard to find? So the fundamental question here is, where is the code for that? Like, I know conceptually that I want to make some change to my application. I need to be able to find the code that will let me affect that change. And organization is sort of the key here. We want to keep all of our code organized so that it's quick to find things when we need to answer that question. So here's an example of a view function. This is like a really long view function that's just got 714 lines worth of view. Now, one of the points that Evan made in his talk was that actually line count is not necessarily something that you need to worry about in Elm as it might be in other languages that you're used to. So intrinsically, just knowing that there's 714 lines here doesn't necessarily tell us that there's a problem. But it's a sign that probably things are going to want to get organized and potentially want to get refactored. So we got all these lines in here, and we say, okay, let's just break these up with a comment. Comments are a great way to organize things. Just say, okay, the header section's here, the body section's here, the footer section's here. Now if you're like, okay, so I'm looking at my page, and I know I want to make a change to the body somewhere, you can kind of scroll through and just see this comment that says, oh, okay, here's where the body starts. So my change needs to happen somewhere in here. This is a really low-cost way to do this. You could also do it with a function. So you could say, instead of having comments to split these things up, I'm going to split them up into functions. So maybe view header, view body, and view footer. So these functions basically accomplish the same thing as the comment. We're not actually sort of fundamentally changing the structure of the code. We're not really fundamentally changing the characteristics of what it's like to work on it. All we're doing is, instead of having comments to break these up, we're just having little helper functions that break things up instead. Notice, by the way, that when we're breaking up these functions this way, we've got 127 lines now moved into this view header function, 349 moved into view body, 238 moved into view footer, but we've also got the extra overhead of those additional function lines. So actually, if you think about it, we have added more lines of code to our program by doing this. Like, we've split this out, and again, more lines of code, not necessarily a bad thing. Not necessarily the thing to focus on when you're thinking about scaling nicely. The main thing here is, okay, yeah, we've made more lines of code, but they're better organized. Like, we did that for a purpose. I would call this usually a net win. This is something that I do all the time, break things out into helper functions. Okay, so more lines of code, but better organized. People ask me a lot of the time, like, hey, how would you actually go about organizing these things? Like, what names would you choose? What directory structures would you choose? Rather than going into all that, I'm just going to point you to an example of this. So this is something that I built, Elm SPA example on GitHub. And it's just got an example of sort of like how I would do this. So if you're wondering, there's also a little short blog post that goes along with it that kind of walks through some of the choices that I made. And so this is a 4,000 line of code, single page application, and I built it using lessons learned from working at No-Red Inc. on our 100,000 lines of code Elm application. By the way, we're hiring. So if you're looking for sort of like, okay, here, what are some good patterns to follow? What are things that I can expect will scale nicely? I'd recommend taking a look at this. Okay, important to note, by the way, that renaming things is a pretty low-risk refactor. Like if you're wondering about like, do I have these names just right at the outset of my project? Have I chosen the right names for everything? If you haven't, it's not going to be the end of the world. Like you can refactor things pretty easily in Elm, and this is definitely the type of refactor that's very prone to like, once it compiles again, it just works again. There are some refactors where that's not necessarily the case, where you're rearranging state, you're changing how things interact with one another. But the type of refactor where you're just saying, I want to change this module name from one name to another, or even a whole bunch of module names from one name to another, is a pretty low-risk refactor. Another important thing to note is that very often, organization follows from creating guarantees. So I don't actually spend that much time, typically speaking, thinking about how am I going to organize my app. It's more that I start thinking about, okay, what guarantees can I create to make my code nicer? And then the organization typically just sort of follows from that. So one of my meta-level pieces of advice for how to organize your app is just actually not to think about organization, but rather to think about guarantees and let the organization follow from that. If you're wondering about how to create guarantees, I can reference another talk given by me, called Making Impossible States Impossible, but this sort of talks all about how to create guarantees in various ways in Elm applications. Okay, so sometimes code gets hard to find as we scale, and the solution here is we want to make the code more organized, and then it won't be so hard to find. What about when code's too big to fit in our heads? This is sort of a thornier problem. So what do we mean by this? So imagine this is our minds. This is like what we can fit inside of our heads at one time. And when the code base is pretty small, there aren't that many concepts to fit in our minds at once. It's just like a very small amount of code to deal with. And this is pretty manageable, right? This is comfortable. It's not really a big deal for us to keep the whole application, the whole system in our heads. Okay, but then let's imagine that we have sort of a bigger application. It's growing, there's more and more code on there. And okay, yeah, this is still manageable, but it's no longer comfortable. This is now like, okay, we're kind of at capacity. And eventually, the code base gets bigger and bigger, and it's just like, okay, this is now just impossible. I mean, I can't possibly keep all these things in my head at once. There's just too much. So what do we do when things get impossibly large, such that the entire system just no longer fits in our heads? So the first thing that I would advise is to solve one problem at a time. Like if your view is too big and you're like, I can't fit this whole view in my head anymore, focus on splitting up the view and finding ways to divide that such that you no longer have a view that's too big to fit in your head, or at least dividing it into pieces that can fit in your head so that you can think in terms of those smaller pieces. Same thing with update. If update gets too big, focus on just update and thinking, how can I make it so that update, which is now too big to fit in my head, is now something that can fit in my head. Same thing with model. Same basic principle, just focusing on saying, this thing's too big to fit in my head, how can I make it so that I break it down into pieces that I can fit in my head? So let's start by talking about view. So here's a view, and it's got all of these functions that we split out. This is the same view that we looked at earlier. So we got view header, view body, view footer. But again, when we broke this up, this is just an organizational thing. Like if I'm looking at view header, view body, and view footer, all of those have the same things in scope as the view itself. They all take the model, and they all return HTML. So what if instead we made it so that instead of taking model and returning HTML, what if we changed the types around a little bit? Like what if we made it so that the header, instead of taking the entire model, just takes the bare minimum that it needs to render. Like it just takes a user, because we're going to render the user's profile picture, and then it takes an int for the number of notifications. If that's all that view header is doing, it's just rendering the user profile and notifications, by doing this, we can make it so that there's less to keep in our heads about the header. So basically, by narrowing the types of the header, by narrowing down what it accepts, we can make it so that, okay, even though there's still this large complex system, it's still got the same amount of stuff going on inside of it, we actually don't have to think about all of it anymore. Now we've got, instead of this whole big system where everything needs to fit in our heads, we've still got the same amount of stuff, but what needs to fit in our heads is shifted. There are some things that we no longer need to care about. We can just put them out of our minds. So maybe that works for the header, but maybe we come to the body and we say, actually the body really does need the whole model. Like, this is a pretty common thing for the body. It's like there's just a ton of stuff in there and the body needs all of it. So maybe there's no opportunity here. Maybe there's nothing we can do to make this any better. But for the footer, it's actually pretty common that you can go as far as to just make it not a function anymore. Like, there's just nothing to keep in our heads. We don't even have to keep our application's current state in our heads because it's just a bunch of links and a copyright notice. So keep this in mind. You can narrow the types to make it so that each individual function is not just a form of organization, but actually a form of being able to keep less in your head. This is also a pretty low-risk refactor. If we're starting with these functions that take model, return HTML, and then we change them such that instead they're taking something narrower, think about what that refactor actually looks like. You're not actually changing the body of the functions at all. I mean, if you are, it's just to exchange something like model.username for an argument called username. It's pretty much the same form as the refactor we talked about earlier with renaming. If it compiles, it's probably just going to work again. This is another great opportunity to refactor, to keep less things in your head in a really low risk way. So that's when view gets too big. What about when update gets too big? So let's say we have this really long update function, like 812 lines. It's got a pretty typical update type signature, message model, returns a tuple of model and command message. And we've got this huge body. It's just got a ton of lines in it. And at some point we're like, okay, but we can sort of break these down a little bit. So there's like a chunk of code that deals with updating the user. There's a chunk of code that deals with updating the feed. Maybe somewhere else there's a chunk of code that deals with updating the article. And we've made these helper functions update user, update feed, and update article. And at first, we do the same thing we did with the view, where we just split these out. We pass the same arguments, message and model. And we don't actually think about narrowing the types. But then, of course, we can say, okay, we've already taken one step here, so these are returning a little bit less. Right? So the view functions were all returning HTML, but these actually are a little bit narrower already, even though we're passing the same arguments, because they're returning narrower values. They're not returning the entire new model. They're not returning a command to go with it. They're just saying, okay, so we got the whole model, and then we just ended up actually returning a user because that's all we changed about the model. Which kind of suggests that there's an opportunity to take this even further. What if instead of accepting message and model, we accepted a string and a user, or a date and a list of entries, or a user in an article? So now we have these functions that have narrowed the types even further. We no longer accept the entire model, the entire message. We just accept the bare minimum these functions need to work with, just like we did with view header, where we, instead of having it accept the entire model, we had it accept just what it needed to render. Now we sort of narrowed things down even further. So here's how the body of the function would change. So instead of passing message and model to each of these, now we're passing just whatever bare minimum we need to make those functions work. Okay, so in summary, we've gone from these large helper functions gone from the large update function that's got message and model and returns a new model and a command. And that's all stuff that we have to keep in our head. And by refactoring this, we've said, okay, actually we can break this down into pieces that take less. So maybe one that returns a user, so we no longer have to think about that part of our application, all the other model stuff that it could previously modify. And then we've taken it even a step further and made it so that we take fewer arguments, such that now it's even smaller what we have to keep in our heads. Okay, so let's talk about the impact that this has on debugging. So let's say we get a bug. Like somewhere, we got this field called photos somewhere in our model. And none of the stuff we've talked about so far deals with photos, but somehow, by the end of update, there's this bug where in certain circumstances, model.photos just gets emptied out. There's nothing in it anymore. This is not what we want. So now we have to go debug it. We have to go figure out, like, why is this happening when we get to the end of update? Okay, so let's say we've got our three functions here. And we're calling set email, format dates, and set author. And these are the three functions that we've narrowed the types down on. So let's think about this. Which of these functions is capable of touching model.photos, capable of causing this bug? The answer is actually none of them, right? None of them work with model.photos. We haven't even seen that yet. None of their type signatures had anything to do with a photo. Now, previously they did. When they had a model, they accepted the model, they returned a model. But now they don't. And so when we're looking at this and we're saying, hey, which of these three function calls could possibly be to blame, it's none of them. We can just immediately rule them out. Which means that as soon as we get to this line in the code, we read through these 116 lines of update, and then we look at the next line, and we say, oh, we just look at the type signature of that function, we say, actually, the bug could not possibly be in here. We don't even need to branch out and go down that road for debugging. We can just skip it and move on safely. So now, in effect, all of those lines have been sort of deleted from our update function for the purposes of this debugging session. So we've essentially gone from 812 lines all the way down to like 270, just by virtue of having split out these smaller functions with narrower type signatures. So we just have fewer lines to debug when we're going through a session like this. Okay, what about the impact on message? So let's say we've got a user interface and it's got a bunch of different sections to it. So there's like a sidebar and there's a header and a footer and a feed inside the main body. And we've got a lot of messages, right? We have this huge long list of messages like these that you see on the screen and then like 34 others down below it. Okay, so we've got a ton of messages and we're like, okay, this is a lot. And when we view it, when we view our model, we have like on input search. And this is something that's like part of the feed. We want to search our feed. A lot of messages, and we say, okay, I actually want to break this out. I want to split it up and say, I want to divide my message up. And I want to say, okay, actually, I want to say these feed messages are grouped together. These are sort of logically connected. So I have my message, which represents the entire page, and then I have my feed message, which is just a subset of that. It's just the things that relate to dealing with the feed. So search, expand, collapse, let's say there's 8 other messages in there. So what can we do now with this additional division? Well, one thing is we need to do things a little bit differently. So when we get to updating the feed message, I mean, we could, if we want, just keep it all in the main update. But part of the motivation here is to try and make it so that we can keep less in our heads when we're updating. Which means we can write this function called update feed, which just takes a feed message and the current model and returns a new model. Now, one potentially cool thing here is that looking at this type signature, I can say, okay, so update returns a model and a command message, but update feed does not. It doesn't return a command, which tells me that, oh, actually, feed can't run commands. That's like interesting information. Now, maybe I can do this, maybe I can't. Like in our case, probably feed message, we have this search thing, probably that needs a command. But it's really important to keep an eye out for opportunities like this, to see if you can actually not only split out your message, but potentially narrow your types while you're doing so. One thing to note is that when you're doing this, now you need to be slightly different about how you're structuring your view. So we can't just say search anymore, like on input search like we could before. Now that we have search moved into this feed message type, we need to compose that with our feed message constructor up here in our main message so that we have the correct HTML message. Because otherwise this would be of type HTML feed message and we need to use HTML.map somewhere else to convert it. That might not necessarily be feasible, though, if we need to have a mix of feed messages and regular messages in here. So using this approach, we can now mix and match. Our view function doesn't need to change its type signature at all. We can just mix and match feed messages and regular messages inside of it. Okay, and finally, what happens when model gets too big? So let's imagine that we have this like scene of complexity in our applications, all this stuff going on. This is kind of a lot to try and keep in our heads. There's still a lot to conceptualize. And what we've been doing here is essentially drawing lines on this, right? We've been saying, let's break this down, let's subdivide it into different pieces. And if we're doing a good job, these subdivisions lead us to simpler subsets of that whole complex system. Like you can look at this and say, oh, this is just tomatoes. Like I can think about these tomatoes in isolation and not have to keep that entire scene in my head. That's pretty nice. But it does matter where we draw the lines, right? Like I could actually draw the lines here and be like, okay, now we have like some tomatoes and some bell peppers. There's like a bunch of stuff going on in here. So I drew lines, I subdivided it, I made it smaller. I didn't actually help myself that much. This is not nearly as nice to work with as if we'd drawn the lines in the right place. So put another way, sometimes we draw the lines and the result is lovely and it's beautiful and it's elegant, and then we can also draw awkward lines and end up with something that actually, even though it seems like we made things smaller and nicer, we made things smaller, but not necessarily nicer. So this is an important thing to keep in mind. So with that in mind, let's look at this model that's, again, really big, right? Lots of fields, like 30 more fields on top of these. And we say, okay, you know, I see an opportunity to draw some lines here. Not only on the model, but also on the message. So the message, we have set name, set email, set phone, set street, and these correspond to the fields in the model. So this is a big form where we need to set the name when the user's typing in the name box, set email, et cetera, et cetera. And then, of course, the last piece here is that we have an update function, and then there are branches of the update that implement all these messages. So set name, set email, set phone, et cetera. So the set email one, for example, would say, take the model and then set email equals email. Okay, so let's say we want to subdivide this. One way we could do that is just with comments, like we talked about before. So we could just add a comment that says, okay, so this is the contact info part of the model. This is the mailing address part of the model. Perfectly fine way to subdivide it. That's an organizational strategy, but of course, it doesn't actually let us keep less in our heads, right? Previously, we had 36 fields total in our system representing our application state. And afterwards, we still have 36 fields. We haven't actually changed any of that. Okay, one thing to note about this is that, so another way we can do this is we can split up the model into a nested record. So we can say, here's the model, and I'm going to make this new type alias called contact, and it's going to have name, email, phone, and those things are now in this other record, this other type alias. And then I can make another type alias called address, and it's got street, city, and country, and now that's a new field in the model. And then now I can think about these things a little bit differently. So what has this done for us? So previously we had 36 fields, and now in this world our total system has 38 fields. So we have all the same fields we had before, but now our model has 2 more. So we actually made it worse. Now there's more to keep in our heads. So, okay, but that's like a pretty minor downside, not a huge deal. It's a little bit bigger, the overall system, but pretty minor downside. Also, another thing changed, which is that before we could reference model.email, and now we have to say model.contact.email. So that's also a little bit worse, but it's like another downside. It's also pretty small, so like whatever. Also, before we had set email, and it could just take email and then say model email equals email. And now we actually have to do a nested update, which is kind of like if you do this let thing, and then okay, so this is also another downside. So kind of left wondering what's the upside? Why are we doing this? How is this so much worse than comments? Well, the upside, of course, is that we have this opportunity now to narrow our types, right? We can write a new function that we could not write before. We can write something called alter address. I don't know what it's doing with the address, but it's taking a string and then an address, not the entire model, and then returning an address, right? So this is the benefit. This is what we're going for. We want to be able to write this function. That's the money. Okay. So we got this this alter address thing that takes a string and an address, but also we can use the technique we looked at earlier and do the same thing with the message, right? We can also make this thing called address message that works only in terms of address. And now I can implement this update address function that's got even narrower types than what we did the previous time. Now we can write update address that only works in terms of address. It takes an address message, which is just the subset of messages that deal with changing the address part of the form, and then an address, and then returns an address. So this is the benefit. This is what we're going for. We want to be able to write this stuff. That's why we're trying to go down this road. Okay, so here's the thing. So if the goal is that we want to write alter address, and then of course the corresponding alter contact for the other part of the model that we split out, let's look at their implementations. So notice that the problems that we had before, that sort of the downsides that we wanted to avoid, went away. We no longer have this nested record update. Alter address is just taking in an address and then modifying that, and alter contact doing the same thing. Also, if you wanted to reference them, you wouldn't have to say address.something.something. You just say address.whatever, contact.email. So this sort of removes all the downsides that we had before. When it comes to narrowing types, these functions don't have the downsides that we looked at earlier. So here's the thing, though. So alter address takes a string and an address and returns an address. And this is what we agreed we're going for. This is the whole reason we're doing this. But this function doesn't take a model. Why do we need to change the model to get this function? We can just call this function, right? Just using arguments that we built up from the model. Why don't we just say, I'm going to call alter address, passing the string that I want, and then just build up this address record using values from the model. Model.street, model.city, model.country. I could just leave the model alone and still get the function. So why wouldn't I do this? Because this is annoying, right? I don't want to do all that every time I call this function. That's a pain. So then there's this thing, okay, yes, granted, we could do this. We could get the benefit without actually changing our data model, but this is annoying. So can we make it nicer? Can we make, okay, not this photo, there's no way to make this photo nicer, but the code, right? Can we make the code nicer? That's a reasonable question. Yeah, there totally is. So what if I told you that instead of calling this function this way, I could instead call it this way? You might be like, that's a type mismatch. Model is not the same thing as address. You can't just pass a model in there and have this work out. This is not gonna do what you want, I'm afraid. Okay, fair point. But then remember how address was defined as this record alias, and it was string, street is a string, city is a string, country is a string. What if we did this slightly differently? What if instead of it being this type of a type alias, we changed it to this? What if we made it an extensible record? And we said, okay, just address just means something that has a street, a city, and a country. And we made our function just take one of those and then return one of those. So now I can call this thing passing a model, works, and then it's going to give me back a model when I'm done. So I've written the function being the money, that's the thing with the narrower types that I wanted to write, but I didn't actually have to change my model. So like, let's compare these two. In the one case, we're taking the extensible record, in the other case, we're not. In terms of narrowing types, in terms of how much we're keeping in our head, what's different about these? Is there anything different about these? I mean, they have equally restricted implementations. Like, the bodies of these two functions are identical. Neither of them can access any more than the other one can, and neither of them can return any more than the other one can. They're also identical in terms of guarantees. As far as debugging goes, we can cross either of these off in exactly the same circumstances as the other one. So basically, if they both let us keep the same amount in our heads, what's the downside? Why not do it this way? Why not indeed? So, looking at this alter address function that takes the extensible record version, we can also take this a step further and do the same thing with our message, right? That was the other thing that we wanted to do, was we wanted to write this restricted version of update that takes just an address message, and then an address, and then returns an address. Same thing completely still works. No downside. So comparing these two, we can actually now write a function that we can make a new model just by calling alter address on the old model, keeping all the same guarantees, not having to change our data model one bit, not having to introduce any new fields to our model, not having to get involved with nested record updates, all of these things, and we still got all the benefits of the narrower types on just being able to work in terms of the address and just being able to work in terms of the contact. Okay, all that without changing our data model. And this, as it turns out, is kind of like what extensible records are for. Evan once told me, by once I mean like 2 days ago in the hotel, extensible records are useful to restrict arguments, not for data modeling. This is just kind of their purpose. If you want to learn more about extensible records, my coworker Tessa Kelly, who's awesome, wrote a whole blog post about them, about various data structures in Elm, and she talks about this concept of like, this is a way you can use extensible records. Okay, so to sum up, we originally started off with 36 fields. We could call model.email. We could do set the email without doing a nested record update. And then in the version where we made things nested, it went from 36 to a total of 38, making the system a little bit more to keep in our heads. We had to say model.contact.email. We had to do a nested record update to work with it. But what we can do is we can focus on keeping less in our heads and use extensible records to get the same benefits that we had. This is sort of the simpler way to do this. And still get all the benefits without having to actually change our data model. Of course, you can do the more complex way, in which case you will, slide transition, nest the records in the data model, which sort of creates these problems, these three problems that we talked about. And then this might lead you to say, now that I've created these problems for myself, I need to find some solutions to these problems, like lenses or something else like that. I recommend just not creating those problems in the first place. Like, it's definitely simpler to say, focus on the money, focus on what the benefit is that you want to get, which is keeping less code in your heads, and you don't need to create these problems in the first place. Okay, so this begs the question, like, how can we actually refactor to make the model itself smaller? Like we said, we went from 36, and we could increase it to 38 fields. Like, how can we actually make the model smaller? Is there any possible way to make it smaller? And that's kind of a hard question, because essentially the question we're asking is, well, the model represents our entire application state. We just like need that much state. Can we refactor it to need less state? Not really. I mean, the model represents the entire application state. Like, reorganizing records, there's just kind of no way to do that in any meaningful way. I mean, yeah, you can sort of technically shrink the field count by combining things and other things. There's various ways you can hide things, which can be a good idea for other reasons. But at the end of the day, just trying to refactor to say, let's just not need as much application state, you probably got to cut features if you want to do that. So again, focusing on the benefit. We want to keep less in our heads. Focusing on functions that take a subset of the model is the way to do that. Okay, so we go from code being too big to fit in our heads to being narrowed. So we had trouble finding our code, we made it organized, had trouble keeping it in our heads, we've narrowed the types. What about duplicated code? So let's say we write this view header function, and it's rendering the user, and it's got the username up in the upper right, and it's, the user's full name. So it's got first name plus a space plus last name. This is in the US how we do names. Obviously in other places it's done differently. And then we do the same thing in the profile, right? We've got view profile, and it's got the same logic, user.firstname plus a space, and then last name. So look at this, we say, okay, there's code duplication here. This is not as dry as it could be, if you will. So what can we do about this? Well, whenever we see code duplication, the first thing we should generally reach for is a helper function. Just write something called full name, and it takes a user, returns user.firstname plus the space plus user.lastname. Then the implementation of these changes a little bit, where we call view header, and it's instead of having this all written out, it's now just calling full name, and view profile is doing the same thing. So in addition to making it so there's a little bit less code here, which is kind of the minor benefit, the much bigger benefit is that now, if we need to make a change to how this works, we can do it in one place. So let's say we're not in the US, and this is not how you make a full name out of its constituent parts, then we can just change that function in one place and not have to go hunt down all the places we used it, potentially missing one and causing a bug. So this is just sort of a good idea. Helper functions are just nice like this. We can also do a similar thing in update. So let's say we've got an update function. Pretend there's more messages here than this, but let's just focus on these two for the present purposes. And we've got this menu that you can click on to open and close, and you've also got a form that you can submit. And we've got this business logic rule that when you submit the form, it's supposed to hide the menu. The menu is supposed to go away. So this is our duplication right here. How can we deal with this? Well, using exactly the same technique that we did a second ago. We can just say, make this function called hide menu, and it takes a model, and then it returns the model with show menu being set to false. So in both places, we're now hiding the menu. Okay, granted, usually I would not make a helper function for something this simple, but let's just imagine that there's more stuff going on there than just setting this show menu to be false. Same idea applies, assuming that we decided this is a good refactor to make. Okay, so we're using hide menu in both places, but we added like 2 lines of code to our file to do this. Can we be clever and not add any lines of code? This will be a great idea. Okay, yes, we can. So one way we could accomplish the same thing with the way the code's written right now is we could just call update again, passing hide menu and the current model, and so it'll just recurse and go back up to the top and go down the hide menu branch, which already sets show menu to be false, and then call tuple.first on the result of that to pull the model out and throw away the command, and then now we have our new model. So this works, but now we've actually coupled these 2 branches of our update, right? Now, whenever hide menu has a change in its logic, like if we want to change what happens when the user clicks the hide menu button, we're also implicitly changing submit form as well. Like we didn't set out to couple these 2, but we did. So now let's imagine that we introduce some sort of new form of analytics where whenever the user clicks hide menu, we want to record, hey, the user clicked on the hide menu button. They actually used that thing. We're trying to figure out if hide menu is a useful button to have. And so we record it, and we're like, cool. Now whenever the user clicks hide menu, not only do we set show menu to be false, but we also set clicked equals true. Problem is that now whenever the user submits the form, we're also doing that. That wasn't what we set out to do, but it's a side effect that happens. So now we're saying, oh yeah, people are using the hide menu button all the time. Every single time they submit a form, you know, it's weird. So unfortunately, this is just a good way to get bugs. Like if we do it the other way, we just say, oh, let's just, you know, we have some potential code duplication. Let's just write a helper function. This doesn't really happen. We don't accidentally couple the entire logic of both of these messages. Instead, we just say, oh, we want to do that in only the case of hide menu? Sure, no problem. We'll just pass this hide menu function a model that's got that one particular change in it, and submit form will be totally unaffected. So basically, if you think about the purpose of update as sort of routing messages that come in from the runtime to some logic that handles those, I think this is a good way to sort of realize that like that's update's purpose and to sort of leave it at that. So I would recommend sharing code with helper functions instead of recursive calls to update. Just make it so that the only way that update ever gets called is by the runtime, not by us, except in tests. Okay, so now, let's say we got a visual designer on the team. Visual designers are great because they make things look awesome and be great to work with. So a visual designer comes up to us and they say, I've got a design for a nice accordion component that we can use in several places in our application. This is sort of like potential duplication up front. We're going to make this accordion, and we know it's going to be in several places in the application, and it's not necessarily going to be implemented just using one function. It's not like these techniques we've been talking about so far where you can just call it, passing some arguments, and then make another function that just does the same thing but in a different place. This is potentially going to be interacting across several different parts of our system. So now we have this question. How can we reuse parts of our UI without any code duplication? So duplicating Panda is good, duplicating code across our UI, not good. How can we do this? So there's a bunch of different, bunch of different ways we can do this, and they have a bunch of different APIs. So yesterday, Greg talked about building reorderable UI, and one of the things he talked about was the APIs that you have to think about, the decisions you have to make when you're building something like this reusable, reorderable UI concept. Now, he was talking about it in the context of a library, like building a package. But the same thing applies when you're building an application. Like, the first question you have to ask yourself is, what API do I want to represent this thing? And sort of a good guiding principle here is just use the simplest API that gets the job done. Again, thinking about narrowing types being one of the keys to scaling, perhaps the key to scaling, try to prefer the simplest API we can come up with that gets the job done. And that can be really, really simple. Let's say we have a subscribe button we want to reuse in a bunch of places. That can just be of type HTML. We just say, yeah, this is a button. It's got a particular class that makes it look a particular way. And it's got some text that says subscribe. This doesn't even need to be a function. You can just say, hey, I want to make a reusable subscribe button. Cool. It can just be of type HTML message. Now let's say we've got this badge, right? This is something that's got to be a function because it's a different badge depending on the user. So we pass in the user. We say this is going to be a link. It's got the href of the user's profile URL. It's got an image, the user's photo. It's got a text for the username. All this stuff put together. This is a reusable badge. So this type signature also works perfectly well for reusing something like this. Let's get a little bit more complicated. Say we got a checkbox. And this is something where maybe we've got some special styling that we want to do to it. And now we're not only passing in the current value of the checkbox, so that's this Boolean for what's currently set or unset, and we're passing in this toMessage function that says, okay, when I get one of these events from the onCheck handler, I want to call this toMessage function to go from the Boolean that the browser says, hey, this is the new state of this thing, to a message that represents updating our model to reflect that new state. So this is another perfectly fine API for creating something reusable. Just a function that converts to a message, as I like to call it, teach me how to message, and then a Boolean for the current state, and then some HTML that will actually render on the screen. By the way, this exact same API works even if we want to have a different implementation. So let's say that instead of using the browser's checkbox, we actually want to do like a custom Bootstrap style checkbox that's made out of just plain old div. We can do exactly the same thing. We still got our toMessage function. We've still got the Boolean for whether or not it's checked. We can use a class list to have it render checked or not. And then we can have on click set fire toMessage passing the reverse of whether it's currently checked. So same API, different implementation. We can just swap it out. And if we do a good job thinking about our APIs, in a lot of cases this will end up being true. Not always, but a lot of the time. Okay. We can also take this one step further and say, oh, actually, we want to add another argument because we want this to be a checkbox with a label. We want to say this checkbox not only has the little check, but also it's got a custom label string that we pass in. So that's another potential API for this. If you want to see sort of a larger example of this, Evan made this library called Elm Sortable Table, and it's got sort of a more fleshed out version of this, and it's taking the same concepts we just talked about, but applying them on sort of like a larger reusable thing. So it's got a config value that you can pass in that sets all these different message handlers. It's got a state value that you can pass in that represents several different pieces of state, like which columns are sorted and things like that. It's got a list of the rows, and then finally it returns the HTML value. Now there's no recipe that fits all sizes here, right? You have to think about what's a good API for this thing that I'm going to reuse. These are all just examples of APIs. This is not an exhaustive list. Okay, let's keep going. Let's build bigger and bigger and bigger. Let's say we want to reuse an entire sign-up form. We want this to show up on many different pages. There's a lot of stuff going on here. One way we could do this is just using the same stuff that we did up to this point. I'm just going to take a drink and let this all sink in. So we got a lot of stuff going on here. We've got a submit form message. We've got set username, set password when the user's typing those things in. Check if the username is available. That's going to need to do an AJAX request to go fetch whether or not the username is available on the server. We got the current username, the current password, potentially validation errors like that username's not available, or you typed something in wrong, or you left something blank. All sorts of stuff could be going wrong here. This is a pretty big function. So maybe we're like, okay, I don't really want to have this, like, I think that's 80,000 arguments. We don't want to pass all those every single time we call this function. So let's see if we can maybe reduce the argument count there. And so we make this config record that's sort of like Evan did in the sortable table example, we just break it down a little bit and say, okay, so we'll have a submit form, set username, set password, check username available. That's sort of the configuration that's independent of the state. And then we'll also have the state itself, which is the username, password, and the current errors. So again, we could split this up however we want, but let's say that we decide to do this. Cool. So now we've got a little bit smaller of a view function. It's only taking 2 arguments, this config and the state, which is cool. But still, whenever we call this thing, we have to pass this 4-field record every single time that we're calling the view, and then also the model.signupForm state. So like, this is better than calling all those arguments, but there's still a lot here. This is still pretty annoying to use. So what we can do instead is we can say, okay, I want to look at my message and say, I'm sorry, this is another downside. So we got the message, and we're like, not only do we have to call view passing these 4 fields every single time, but also our message has to have submit form, set username, set password, check available, and that's just sign up form specific. The rest of the page doesn't need all that. Every single page where we use this thing, now we have to add all 4 of those messages. That was not a big deal when we had the checkbox example. In fact, probably we needed to have one of those messages anyway, even if we weren't building something reusable. But in this case, yeah, this is all just stuff that needs to come along because of the API we've chosen for our sign-up form. Also, as comes with messages, we also have to update change our update function to have branches for each of these. So now every single page needs to have all 4 of these messages. This is a lot of work just to use this sign-up form that we just want to have in a bunch of places. So a way we can solve this is by giving sign-up form its own message type. And say, this is like a sign-up form message. This is separate from our pages message. Again, we're splitting these things out, and we're saying, okay, sign-up form has this message type. It's got submit form, set username, set password, check available. And it's also got its own update function that just works in terms of that sign-up form thing. So this looks like a similar pattern to what you're used to with update, message, model. We called it state instead of model, but it's the same basic principle. And then it returns the state, the new state, and then a command message. And then what we're going to do is we're going to call this from our original page and say signupform.view, passing the current model signupform state. And then at the end, we're going to say html.map to convert from the signup form's message type to the page's the page's message type. And then in update, we're going to have to do the same thing. We're going to have this signup form message, and we're going to call signupform.update, and then do command.map to change it back into the page's message type. So there's a really important observation here, which is that the reason we did this was to solve a problem. Like, this is the purpose of html.map and command.map. It's to avoid the specific problem of having too much config, of saying, yeah, we could have built it in that other way, where we had this enormous config record, but that was really annoying to pass like 4 fields in this record every single time we wanted to call view, and to instantiate 4 new message types in every single message on every single page, and to handle those in 4 places on update. This lets us collapse it down and just say, yeah, we'll just have one. We'll just do command.map in one place. Let's do html.map in one place. That's going to be a lot less trouble than the alternative. So instead of doing all this, we can collapse it down into just the one line. Okay, so now let's say we get a new feature. Our designer comes back to us and says, hey, I want to implement a cancel button on that sign-up form. So when the sign-up form is open, you can press a cancel button to close it. Pretty reasonable. But there's a little bit of a subtle problem here, which is that the cancel button is going to be rendered by signupform.view, but the message that actually says, hey, go ahead and close this, is therefore going to go to the sign-up form. But the logic for whether or not to show the sign-up form has to live in the page. So if the page's view says, hey, if model.signupForm visible, then render the signup form, well, how do we change signup form visible when the logic that describes the handling the user interaction of clicking the cancel button is in a completely separate code base? How do we do this? Well, the answer is that we change the type signature of the form's update function. So we say, instead of taking message state and returning state command message, we just have it return one more piece of information, which is whether or not it's supposed to be open. So now, when we're over in our pages update function, we can just call form.update like we would before, down here, passing the usual submessage, passing the usual model.form state, but now what we get back is a 3-tuple. We've got new state, command, and is visible. So by calling it, we've just obtained this extra information as to whether or not the form is supposed to be visible. And now when we're processing this branch, we can say, not only are we going to update the form state to the new state, which is what we'd always do anyway, but also we can set the form's visibility. So by doing this, by changing the type signature of update, we've effectively made it so that the caller is now aware of this extra piece of information. And I've heard people say, like, hang on, this is an update function. Update functions don't look like this. Like, update functions have to return model and command message. That's what it means to be an update function, which is not really true. It's actually just that program takes updates that look like that. But update is just a function, and functions can return stuff. Like, you can write whatever function you want. It's fine. Like, maybe you write an update that looks like the one that program expects. Maybe you don't. Maybe you write one that takes an extra piece of information. Maybe you write one that returns a record. That's totally allowed. You can do that. It's fine. If you want, you can have update return a result, or maybe some custom union type that you came up with. All of these are completely fine. Maybe, in fact, ideally, you find that, oh, actually, we don't need to return command message because we don't do any commands, right? We can actually use this as an opportunity to narrow the type. Or maybe you go the other way and you say, actually, I need to pass some extra information in. This update function not only needs the message in the current model, maybe it needs this sort of session that applies to the application as a whole. This is something I do in the SPA example. All of these are completely fine. Functions can do whatever you want. The only thing is, at the end of the day, at the top level, you have to get them down into the format that program expects. But other than that, everywhere else, you can do whatever you want, whatever you need to make your program as nice to work with as possible. So, when you're saying, I want to build something reusable, the next question is, hey, what should its API look like? And these are all examples of what the APIs could look like. We could have just plain old HTML for the subscribe button. We could have user to HTML message for the profile badge. We could have something that takes an actual function that says teach me how to message for the checkbox. We could have the coupling of both the view function that takes state to HTML message as well as the update function for the sign up form. All of these are potentially reasonable APIs, but it's important to keep in mind, again, use the simplest API that works. Keep the types as narrow as possible, because that's what's going to let us keep the least amount in our heads as possible when scaling our application. If you want a bigger example of this that's not a library, the SPA example has a couple of examples that fit this similar pattern. And so view timestamp takes an article, returns HTML. That's a way that we reuse things. Article.view looks a little bit like the checkbox example, where it takes an article and then returns a message, and then an article, and then that renders the article like that. And then, of course, there's also a bigger example for the feed, which has feed.viewArticles, which takes model, returns message, and this is a feed message. And then feed.update, which, again, update can take whatever it wants. It takes the session as the first argument, and then a feed message, and the feed model, and then returns the feed model and command message, command feed message. So lots of examples in there of different APIs you can choose to reuse things. Okay. Oh yeah, so I need to go on a little bit of a tangent here when talking about scaling with reuse, like in the context of reuse. And that tangent starts with a talk I saw at Go to Chicago, which was programming across paradigms. And Ajana gave this great definition that I really like of object-oriented programming, which is basically objects are all about keeping state to yourself, and you receive some messages from other objects, then you respond as you see fit. So an object is basically some state in the form of properties, and then methods which can access that state. And because objects have state and they have methods that can access that state, they can also communicate to affect each other's states, to change what's going on with the other objects. So this is probably something we're all familiar with, object-oriented programming. It's very popular. You may have heard it. So you can also have trees of objects. So a tree being a structure where you have a parent and a child, or some number of children. And if you have a tree of objects, then objects can communicate. Trees have parents and children. So you can have this notion of parent-child communication. You have a parent object and a child object, and they can talk to each other across the tree. Here's a tree of objects that may be familiar to some of us. This is what's known as the document object model, or the DOM for short. This is a tree of objects. And because it's a tree of objects, we can do parent-child communication. So here's an example of this. Let's say we have this box, and it's like, hello, Paris, and there's a little X in the upper right. Now, when you click the X, that's going to be a DOM element, and then it's got a parent that's probably a div or something that represents the entire box. And one way we could model this interaction of having it close is when you click that, the object for the little X button talks to its parent, the div, and says, hey, parent, close yourself. And then the parent div says, cool, I'm going to modify my own internal state and close down. Okay, cool. So that's an example of parent-child communication. And this is sort of like the paradigm I was used to for how to scale object-oriented systems. Now, not all trees are trees of objects, right? So the DOM is a tree of objects. File directory structure, not a tree of objects. That's just a tree of flat files. They're just data. They don't have methods. They're not objects. So you could ask this question, hey, how do directories do parent-child communication? But the answer is, that doesn't really apply here. I mean, they don't. They're not objects. I mean, how would you say, hey, data directory, talk to your parent and tell it to do something? You just can't. It's a different paradigm. So this is sort of the idea of like data without methods that happens to be organized in a tree. And we operate on data like this using decoupled procedures. So like ls, rm, mv, stuff like that. Different paradigm. So similarly in Elm, we also have a tree of HTML values. This is how we represent our views. And this is also data without methods because Elm doesn't have objects. It's not object-oriented. It's just a language without that entire paradigm. So when we have a tree of data without methods, that means that we're going to operate on it using decoupled functions, right? So like view, map, stuff like that. No methods. And because of that, that means that there's also no notion of parent-child communication in this tree structure. It just doesn't have it. You need objects for that. So we saw, though, that we can still, without the notion of parent-child communication, still model that same interaction. Right? So canceling the sign-up form to close it is fundamentally the same set of characteristics as when we were closing that box a second ago in the object-oriented style. The only difference is that we didn't do it by parent-child communication. All we did was we just returned more information from form.update. Right? This is nothing but pure function calls. We just said, hey, I'm going to call this function. It's going to return some extra information to the caller, and then that's all you need to model this interaction. So, it's important to note, by the way, that one of the points that Anjana made is a paradigm is a mindset about how you look at your code. It's not necessarily about the language. So we know that JavaScript is an object-oriented language, but you also may have heard that you can program JavaScript in a functional style if you choose to. Like you can take this object-oriented language that was designed for object-oriented programming and instead use it in a functional style if you like. Similarly, you can also take Elm, which is a functional programming language that doesn't have objects on purpose, but you can still use it with an object-oriented mindset if you want. That works. It's not necessarily recommended, but it works. One of the important things to note is that your data modeling strategies vary by a paradigm. This is something that a choice that you can make about how you're modeling your data, and the mindset that you have affects how you're doing this. And this absolutely affected me when I was a beginning Elm programmer. So let's say that, so Elm's paradigm is sort of based around this idea of a single source of truth. This is sort of the fundamental idea of the Elm architecture. One source of truth instead of object communication. And so let's say a visual designer comes to us. Let's see how this plays out. And they say, hey, I made a design for a nice drop-down component that we can use in several places. So again, first thing that happens when you encounter this scenario is you say, what's the API I want to use? Now, me in an object-oriented mindset, what I would have said is, okay, I'm going to model each drop-down as an object. I'm going to have some local state that stores whether the drop-down is open or closed. And I can open or close it with a click, with a touch, keyboard, etc. There's a problem with this, though. So what if two drop-downs end up in the open state at the same time? Like, that's entirely possible in this system, but drop-downs have this business requirement that only one drop-down on the entire page can be open at once. And lest you think that this is a contrived example, I actually ran into something almost identical to this when I was working on the single-page application. I was playing around with the React Redux single-page application example, and I ended up with a tab bar that has two tabs selected at once. I just did. I wasn't even trying. I wasn't like hunting for it. It just happened when I was clicking around. I took a screenshot. And you know, it's important to remember that this can happen even in React Redux. Like, React components are objects. Fundamentally, this is an object-oriented system. Yeah, you can do it in a functional style, but at the end of the day, that's the paradigm. Under the hood, you have local state, you have communication. That's why in React tutorials, they talk about parent-child communication, because you have a tree of objects there. And one of the consequences of having this tree of objects is that you can end up with bugs like this. Okay, what about the single source of truth paradigm? So how I would model this now in Elm is I wouldn't actually think about whether the dropdown is open or closed in those terms. I would put in my model which dropdown is open. Have a maybe dropdown ID. Either 1 or 0 drop-downs are open. If I do it this way, it's not possible to have that bug, right? I've made this impossible state impossible just by thinking about data modeling from the perspective of single source of truth instead of object-oriented. And lo and behold, when I designed this, I made it so that it is actually impossible to have multiple tabs be open at the same time. That's not actually representable. The thing is, familiarity is a hell of a drug. And when I was first getting into Elm, I didn't realize all this yet. I mean, I was used to scaling systems in an object-oriented way, and so when I came to Elm, my instinct was to be like, okay, so I know how to scale things with like parent-child communication and these objects, and here I don't have objects. So can I get them? Like, how can I scale without objects? I don't know how to do this. I hadn't watched the preceding part of this talk. So I was like, okay, well, hang on. So if I have like trees of objects, I wasn't really thinking in these terms, but kind of conceptually, like parent-child communication within objects within the tree. And like, okay, so in Elm, you have this model view update triplet, right? And stay with me. So if you got a model, you got a view on that model, and you got an update, like that's local state, essentially, and I can update that local state. So I essentially, like, if you kind of squint and look at it just right, like, maybe I can use this to end up with the familiar scaling strategy that I'm used to. So I did this, and I tried it. Spoiler alert, I wasn't happy with it. But you can do it. So basically, we've looked at the subscribe button, the badge, the checkbox, all these different APIs, and sort of what you can do instead of this, instead of saying, let's just go with the simplest API possible, is you can say, okay, I need to reuse things. Boom! What if every single one of these had this exact same type signature? Then we would have something that felt a lot more like an object-oriented system that we could work with. Here's the problem, though. We've been talking a lot about how to successfully scale Elm applications. And it kind of like all came down to not something like OOP in Elm, but rather focusing on keeping less in our heads by narrowing our types. Like that's what we've been doing to successfully make things easier as we get our system and narrow things down so that there's less that we have to keep in our heads. But the problem is what we've done here is we've gone the wrong way. We've taken these simple APIs and we've broadened their types in every single case. In some cases, we actually introduced new functions that needed to exist just to try and use the object-oriented paradigm in a functional language. We've actually made it harder to scale. We're working at cross purposes. On the one hand, we're going through and trying to simplify things and narrow the types. But on the other hand, by doing this, I was doing this to myself, was making it so that I had a lot more to work with just to keep the same system in my head. It was a way of modeling the same UI in a much more complex way. So, in the same way that narrower types let us keep less in our heads, the key to scaling is doing this and going with the simplest API that gets the job done. So, in summary, when we've got a small app, and we're trying to take it to a big app, the basic pattern that we want to follow is we want to just build more stuff, discover what we can about how we can split things up. Once we've got more stuff to look at, refactor to change things based on those discoveries that we learned. Code's going to get harder to find. It's going to get too big to fit in our heads. It's going to get duplicated. This is going to happen as our code base gets bigger. But if we do a good job, we can keep it organized, choosing good names for things, refactoring when we think of better names, adding comments. We can narrow the types to keep less in our head, and we can reuse things to avoid code duplication while still letting things scale up and up. Renaming things is a low-risk refactor. Important thing to remember. Usually once it compiles again, it works again. Same thing with narrowing types. We want to follow this paradigm of a single source of truth instead of object communication. Just think about when we're designing our APIs, remember, single source of truth is the key. We want to use the simplest API that gets the job done. Solve one problem at a time. If view gets too big, focus on making the view fit in our heads. Update gets too big, focus on making update fit in our heads. Model gets too big, same thing. Goal is to keep less in our heads, and the tactic that we use to get things to keep less in our heads is narrowing types. We've got a library example in the form of sortable table. We've got an application example in the form of SPA example. If you want some more data on this, I did this course for front-end masters. There's a section on scaling towards the end. I'm writing this book, Elm in Action. You can buy part of it right now, and there's going to be a chapter on scaling, but I haven't written it yet. But these are the basic ideas. So hopefully this was helpful. Thanks very much.